Alright, next video is about analog indicator, moving analog indicator. In this case we are using an analog input just for the demonstration. So we have a potentiometer which is connected to my analog input of Allen Bradley. We have an Allen Bradley analog card which is connected at I:1.0. This is the address which is reading the analog value. So if you see here, this value is reflected by this potentiometer. So if I change the potentiometer, you'll see the value will change in real time. Okay, so the minimum value I get is 32-bit, and this is giving 0 to 5 volts. So the 5 volt will give me eventually 16,216 bits. So this is the range from 32 to 16216. Alright, let's read this value in the SCADA screen using the element analog moving indicator. So what we can do is we can drag this here. Okay, now this is having some ranges. Okay, now ranges means if you click on that, you will see range high, range low, process value, high alarm, desired high, desired low, low alarm. So the highest range we have 16216. So this will be 16216 and press enter. This is the maximum value. Range low we have is 32. So let me enter 32. Process value, it is the value which you need. Okay, so you can make it, let's say 8,000. The high alarm, now the alarm maximum is this one. Let's say at 15,000 we need the alarm, so you can give 15,000 as the high alarm. Desired low value, this is the minimum value you desired. So let's say this is the highest, and desired is between let's say 6,000 to 7,000. So high is 7,000, desired low could be 6,000. Okay, low alarm is at 10, so you can have low alarm at 100. High alarm we have at 15,000, low alarm we have at 100. The desired is between this one, these two. Okay, now this is the process value, which this is a pointer, but process value we need from this potentiometer. So all you have to do is make a tag. So you can go to tags, a new tag, OPC tag. This is the tag of this value I:1.0. So you can take ignition server from the devices under I. This is I:1.0. This is the whole resistor. Click OK, apply. And we need to change it. We can write analog, apply, and OK. So this is the tag. You can see the value is coming here as well. This is reflected by this value. So if I again change the potentiometer a little, these values will be reflected here. So you can just drag this analog value to this element. Now this is going to read what is going to happen here. So if I go to run, this was the desired. So you can see visually from the screen the desired value. So this is decreasing. If I go, I need a desired value. So I will just see my screen and adjust my pointer because we have set this limit. So this is 6576. So this is the 6576 because the range is from 6 to 7,000. So this is in between. If you want to read the value here, what next you can do is you can take an LED display next to it, something like that you can do, and you can tag the same value here. Okay, and run it again. So this is the value coming, and this is reflected as a numerical value here as well. So that's how you can read analog moving indicator and display the range in bits. But somehow you may need the ranges in voltage or frequency, or if you're reading a feedback, could be in RPM. So you can do the scaling in your program, and you can store the scaled value in a data register, which you can read again in this moving analog indicator. This we'll be doing in some of the projects when we are going to read the feedback from the drive. Okay, so let's see what we have in the next video. We'll see the cylindrical tag and level indicators. Alright, if you have any doubt in this video, you can get back to me. Thank you.